Hi friends, today we are going to solve number line jumps from the algorithm implementation part. The given problem statement is you are choreographing a circus show with various animals. For one act, you are given two kangaroos on a number line to jump in the positive direction towards positive infinity. The first kangaroo starts at location x1 and moves at the rate of v1 meters per jump. The second kangaroo starts at location x2 and moves at the rate of v2 meters per jump. You have to figure out a way to get both kangaroos at the same location at the same time as a part of the show. If it's possible, return yes, otherwise return no. Okay, so here is an explanation. Let's look at some input. So basically the sample input will be 0, 3, 4, 2. 0 is the initial position of the kangaroo. 1, 3 is basically the rate at which they are moving, the velocity. The 4 is the position at which the second kangaroo is starting to jump, and 2 is their speed. So as you could see from this diagram, both of that kangaroo would jump at a rate and second kangaroo is jumping, and they would be intersecting. They would be at the same position after say jump number 4. Okay, so this is the basic idea. Means basically you have to make sure that you have to find out if it's possible for both the kangaroos after n number of jumps to be at the same position. And the total number of jumps can be varying. Means for kangaroo 1 it could be n number of jumps, and for kangaroo 2 it could be m number of jumps. So jumps number does not have to be the same, but the position at which they are after x amount of jumps would need to be the same. So this is the basic idea. Here's one more input. As you could see from the explanation, the second kangaroo was starting at a location that is ahead, further to the right of the first kangaroo starting location, and because the second kangaroo moves faster than the than the first kangaroo, it is already ahead of the first kangaroo, and first kangaroo will never be able to catch up. So for example, suppose a kangaroo is already ahead of its peers and is also moving faster than its peers, then there would be no way that the peer would be able to catch up with that kangaroo. So in that case we could return no. So let's do that. If x1 is greater than x2 and its velocity is greater than v2, return no. If x2 speed is greater than x1 and v2's speed is greater than v1, return no. Once we have done that, let's write a while loop. Okay, so this is basic idea. We would be incrementing this while loop till x1 and x2 is of the same value. And once it is the same value, if it reaches that, would be basically returning yes, else would be returning no. Let's run this code, but this code will suffer from runtime error. Let's submit it. Let's run it. As you could see, it passed both the test cases successfully. Let's check for the submission. as you could say, it is suffering from runtime error. The reason for is that if they are not equal to, if x1 and x2 is not never, there could be some instances where they would never be the same, and in that case it is just going to an infinite loop. It is not uh, this while loop is not getting closed and is going into infinite loop, so thus we are facing a runtime error. One way of solving this is to write a brute force method. If we look at it, the x constant is 10,000. So let's write a count value. If count equal to 0, we'll be basically would be looping through this loop to a count of 10,000 instances only. Once that count is over, we'll be basically returning no. So this is the basic idea. Let's submit the code. Oh, sorry, I just forgot to increment the count. Plus equal to 1. Let's submit the code. It will take some time to execute. The reason being internet is slow, but can't help that. As you could see, it passed all these test cases successfully, but the question is our solution right or wrong? Then the answer is it's both, to be honest, because it's a brute force approach. There could be instances where the value or the count value could be in millions. So in that case, it would be failing miserably. So one way of writing a proper code, but it would increase the complexity. But let's try that. If x1 is greater than x2, x1 comma x2 would become x2 comma x1, and v1 comma v2 equal to v2 comma v1. And now it would be checking the distances, which would be x2 minus x1. The reason for doing this is that we would be making sure the larger value is always at the first. So basically it will always be returning us a positive value, or it could be v1 minus v2, and we'll be writing a flag variable, flag equal to false. Now let's check. If our d is equal to 0, then we know. If our d is equal to 0, then the flag is true. The reason being the distance of x1 x2 is same. And at the next instances, elif flag equal to d percentage or the remainder equal to equal. This is a basic mathematical formula. Elif r should be greater than 0, and else the flag would be false. Now let's print it. If flag it's true, then we'll be printing out yes, else it'll be printing out, or it'll be returning, right? No. Let's run this code and let's submit this code. The basic formula is stating that if the distance is provided, then at which pace and at which rate would be means the value of the velocity, which would be basically the minus v1 minus v2, if they would be able to reach out to v1. It means if the both of the kangaroos instances or the current location would be the same, if it's possible or not, by using that formula. And that's the basic idea. As you could see, it also passed all the test cases. But one thing is that this value which has been given, that was of big O of n and big O of 1000. To be honest, the last one, this one is just few condition check, so it's not even big O of 4 or 5. Very it's done in a very simpler. It's a bit more complex, but the time complexity of this code is very less. So this is the basic idea. And as always, if you have a better approach of solving the same problem with an even better time complexity, or even better, how to say, even easier code to understand and read, then comment below or send me those links. And as always, send me your feedbacks in the comments so that I could keep on improving. And as always, thanks for watching and stay tuned.